So we have already started Laplace transformation, and in yesterday's class we have discussed the very basics of Laplace transformation and what are the Laplace transformation of standard function. Also we have derived that, and one application to the network theorem also we have discussed little bit. So let us today start with the inverse Laplace transformation. So inverse Laplace transformation is nothing but S to T domain transformation. What we have done yesterday, we have to do the reverse thing. Meaning that if some signal or function or system, whatever may be, is expressed in terms of S parameter, then using inverse Laplace transformation we can have its time domain or T parameter equation. So that is very easy, and there are a few methods. One is long division method, and one more is that is partial fraction method. Today only we shall try to learn one method, that is partial fraction method, and it is very easy. Probably you have learned in mathematics class. You just I have given some PDF. You see, you go to I have given 3 problems regarding inverse Laplace transformation. You just open that. Let us start with problem, because partial fraction method already you have learned in mathematics, isn't it? So this is very easy. Let us solve only 2 problems out of 3. We'll try to solve 2 problems. Then that partial fraction method for inverse Laplace transformation will be clear to all of you. Have you opened that? Let us consider the first problem. Very easy problem. Obtain inverse Laplace transformation of 10 to the power 4 divided by S into S plus 250. This will be a single page PDF. Second PDF. Second one.
Sir, PDF টা কম্পিউটার স্ক্রিনে শেয়ার করলে ভালো হতো।
You have not got that PDF. You just open that. It will not be clear in computer screen actually. Rather, it will be clear in your phone or laptop, whatever maybe. I have sent already.
Okay, sir.
Second PDF. It is of only 1 page. I have sent 3 PDF. One is of 6 or 7 pages. Second one is of 1 page, and third one is of 2 pages. So you just open the second one, that is of 1 page. Open first. Inverse Laplace transformation. Have you opened it?
Yes, sir.
Yes, sir. You see, I have given only 3 problems related to the inverse Laplace transformation. So consider the first one. First one is obtain the inverse Laplace transformation of first function, that is fs equal to, it is given, fs equal to 10 to the power 4 by s into s plus 250. Isn't it? So you see that denominator polynomial is of 2nd degree, isn't it? So we can go for 2 functions, summation of 2 functions using partial fraction method. So we can write that 10 to the power 4 divided by s into s plus 250 equal to, we can write a by s plus b by s plus 250. Can we write?
Yes, sir.
Now you see, now we have to calculate the value of A and B. If we are able to calculate the value of A and B, you see A by S. Consider the first function, that is A by S. So what will be the time domain function? Where A is a constant. In S domain, suppose the function is A by S. So in time domain, what will be the function?
UT.
Nearby store में जिसमें कौन सा है? Hey,
Sir,
In
only
time
A,
domain?
sir. Sir, only A.
Only A.
Only A.
Isn't it? It actually 1 by S, it is the step function, isn't it? A by S, this is step function.
easy
So it will be,
Question on
isn't
too
it?
many.
Similarly, for the second part, B by S plus 250. What will be
Sir,
it?
sir, B into e to the power minus
5 रुपये को देगा
250t.
250t, yes. So, if the function, if we write 10 to the power 4 by S into S plus 250 equal to A by S plus B by S plus 250. If we can divide in two partial fraction, and if we are able to calculate this constant A and B, can you calculate the value of the constant A and B?
Yes, sir.
You can easily calculate, isn't it? 40 and minus
Yes, sir,
40.
40 and minus 40.
So A equal to 40 and B equal to minus 40. So ultimately we are getting 40 by S minus 40 by S plus 250. So what will be the time domain function small f of t? 40 minus 40 e to the power minus 250 t. Isn't it? So this is the partial fraction method. If it is a degree of 3, then you have to go for dividing 3. Then you can easily find out its inverse. Isn't it? Or it is in the form of known Laplace transformation of a standard function, so we can have its time domain expression. Isn't it? Similarly, consider the second one. Second one. Can you solve? Second one. Second one
Yes,
is
sir.
50 by S square plus 2S plus 2. So again, denominator polynomial of degree 2. So we have to factorize this one, isn't it? So what will be that? It will be 50 by S plus 1 plus J into S plus 1 minus J, isn't it?
Sir, we can also compare it with omega by omega square s plus a s whole square plus omega square.
Yes, you can compare by, but in this case you cannot compare with that, isn't it? It is not, yes, you can do by s square plus 2. This is one function and 2s. In that fashion you are going to, but here it is not possible. Isn't it? Like the Laplace transformation of
Yes,
sine
sir, right.
or cosine.
Yes, sir. Yes, sir.
Yes.
Of that sign.
So here you have to factorize it. So 50 by s plus j into 50 into s plus 1 minus j. You calculate. So we can write this is equal to again a by s plus 1 plus j plus b by s plus 1 minus j. Now you calculate the value of a and b. What will the value of a? You calculate it. A equal to how much you are getting? A equal to A will be equal to 50 by s plus j minus s plus 1 minus j, where you have to put s equal to minus 1 minus j. How much you are getting? A equal to? Anyone? A equal to? Have you calculated the value of A and B? Very simple calculation. So 50 by s square plus 2s plus 2 equal to 50 by s plus 1 plus j plus 1 minus b by s plus 1 minus j. Now you have to calculate the value of the quotient, that is A and B. A equal to then? A will be equal to 50 by s plus 1 minus j, where s is equal to minus 1 minus. And if you do the calculation, then what you are getting? Anyone have? Have you calculated the value of A and B? Hello? Am I audible to all of you?
Yes, sir.
Yes, sir.
Audible.
So, have you calculated? Very simple calculation. So A will be equal to how much? 50 by s plus 1 minus j, where a minus 1 minus j. You put that. So that will be 50 by minus 2j. So that is equal to 25j. And b equal to minus 25j. I think you have some confusion. Do you have any confusion?
Sir, are you telling to break the denominator into the roots?
Yes, here you see denominator is it is second degree equation, that is s square plus 2s plus 2. So we can write this as s plus 1 plus j into s plus 1 minus j. So
Samir, please mute your mic, Samir.
okay. So we can write now fs equal to 50 by s square plus 2s plus 2 equal to, we can write 50 by s plus 1 plus j into s plus 1 minus j. Isn't it? We are expanding this s square plus 2s plus 1 in this form. Now we want to have two partial fraction to having degree 1. So 1 we can write a by s plus 1 plus j plus b by s plus 1 minus j. Where a and b have some constant, we have to calculate that value. So here we have written 50 by s plus 1 plus j into s plus 1 minus j equal to a by s plus 1 plus j plus b by s plus 1 minus j. So from this, can you calculate the value of a and b? Easily you can calculate. You multiply both sides by s plus 1 plus j. Then what? Left hand side will be 50 by s plus 1 minus j. Right hand side will be a plus b by what? B by a plus b by s plus 1 minus j into s plus 1 plus j. Where if you put s equal to minus 1 minus j, then that b by that b into that parameter will become 0. So a will be equal to 50 by s plus 1 minus j, where s equal to minus 1 minus j. So you put that value, so that will become 50 by 2j minus 2j, sorry. So 50 by minus 2j equal to 25j. Similarly, you can calculate the value of b. So that will be minus 25j. So ultimately we have got now the equation fs equal to 25j by s plus 1 plus j minus 25j by s plus 1 minus j. So now what will be the f of t, small f of t in time domain function? That will be, for first function, j into 25 into e to the power minus 1 minus j into t. And for the second function, that is then minus 25j to the power minus 1 plus j into t. Isn't it? Any confusion regarding this inverse Laplace transformation? If you have any confusion, please tell me.
The need to break this into partial fraction, it can be solved by using a normal formula. It is simply given 50
If
by
can
8.
solve.
But sir,
50
that sir, this method is easy, and the method you are solving, sir, is hard. It's long.
This is up to you. There are so many methods. One is long division method. You can go for that. This partial fraction method, or directly you can use some other formula, like here you can use that transformation of sinusoidal wave. That
Yes, sir,
also
sir.
you can apply.
Sir, it is question is 50 by s plus 1 whole square plus 1 square. It is simply in time domain. It is
Yes.
it is simply 50 into
That
e to the power minus 2 sin t.
Yes, that also you can do. There is no harm.
Yes.
That sinusoidal function is ultimately, the answer will be ultimately same, because it is also, that also you can plus 1 whole square plus
Sir,
1 square.
your method also results into the same answer. That is.
Yes. I am using only partial fraction method. That's why. But you can solve it that way. That is 50 by s square plus 2s plus 2. You can write 50 by s plus 1 whole square plus 1 square.
Yes, sir.
But in that way also you can solve. There is no harm. Okay.
Yes, sir.
But here only I am using only the one method, that is partial fraction method. But that method you can easily use, because that is also that 1 by s square plus omega square. That formula you are having, and some shifting. So you can do that. There is no harm. Okay. So in this method, actually we have applied partial fraction method. That's why you are thinking in this case it is little bit complicated. In that case, you can go for that sinusoidal multiplied by e to the power something, isn't it?
Yes, sir. Yes.
Okay. So I think you can solve any this inverse Laplace transform problem. If a function is defined in S domain, you can shift it to the time domain. Okay. For that, and the most popular method is partial fraction method. In this specific problem, you can directly use that because it is a second degree equation. That's why you can, if it is third degree, fourth degree, then you have to go for that partial fraction. Though some other methods are also there, like long division method is also there, but that is not popular. There you can get only approximate answer. But in this case, what you are telling that and what we are getting that from this partial fraction method, are ultimately the answer is same. Because sinusoidal is nothing but a composite function of composite exponential function. Okay. Okay. So I think that you have the knowledge how to work with this partial fraction method. Okay. Now let us go to the application of Laplace transformation, and that is very important for this network theorem syllabus. Now you open the first PDF. You open the first PDF. Have you opened first PDF? First PDF, first page.
Yes, sir.
Now see the heading. It is step response of RL circuit. So step response means output, and in this case we have calculated the current, because this is a very simple network. It consists of one resistance, one inductor, one switch, and one source input voltage. Why step response? Here we have considered that input is a step function. If input is a ramp function, then we can call it ramp response of RL circuit. If input is sinusoidal, then we can call sinusoidal response of the RL circuit. If input is impulse function, then we can say that impulse response of RL circuit. Why RL? Because it is having only two components, R means resistor and L means inductor. Clear? Now see this circuit. So here DC voltage, since it is step response, so it is having some constant voltage source, and we are thinking that constant voltage level is V volt, one switch S, one resistance R, one inductor L. So if we think that when switch is closed, then if we apply KVL to this circuit, then we can easily write that V equal to R into IT plus L ddt of IT. Isn't it? Can we write this? First equation. We have written this using KVL. V equal to R into IT and plus L ddt of IT. And here our assumption is current flowing through the circuit is IT, and our intention is to calculate that value of the current IT. So can we write this, the first equation?
Yes, sir.
Okay. Now see, so this is the equation. So ultimately we have got an equation that is V equal to RIT plus L ddt of IT. Now our intention is to calculate I of t. Now it is up to you. You can solve this equation using classical method. This is a differential equation. You can easily solve it, isn't it? By classical algebra you can easily solve it. But here we shall try to solve this using Laplace transformation. Because Laplace transformation, if we use Laplace transformation, then sometimes that solution of this current solution method may be sometimes it becomes simpler. And one more advantage is that Laplace transformation takes care of the initial condition of the differential equation automatically. And we have learned one method, that is T to S domain mapping technique, and that is termed as Laplace transformation method. So we shall try to apply that Laplace transformation and inverse Laplace transformation to solve the differential equation. Here we have to solve this equation to find out I of t. So this time domain equation, the first step is to apply your Laplace transformation to the left hand side and right hand side of the equation to have its S domain expression. So in left hand side only v, when step function, if we take the Laplace transformation, then what you will get? Laplace transformation of v, where v is a constant, or v is a constant. So Laplace transformation of a step function, basically, what will be that? V by s, isn't it? Are you getting my voice?
Yes, sir. Yes.
Yes, sir.
So left hand side we can write v by s. R in time domain, R into it. So what will be the Laplace transformation of it? That will be I of s. R into s. Then L is a constant L, and what will be the Laplace transformation of ddt of it? Differentiation function. Already you have learnt differentiation s into is minus I0. See this I0 is the initial current. You see, Laplace transformation takes care of the initial condition automatically. Whenever you are transforming, coming I0. What is I0? Before closing the switch, what was the current? Initial current. Sometimes it may happen that circuit is having some initial current. So whenever you are doing this transformation, you see that Laplace transformation automatically takes care of that initial condition. Isn't it? For this case, we are assuming that switch was open for a long time and it was closed at t equal to 0. Meaning is that we are assuming that initial current is 0 for this specific case. But in some problem you may find that some initial currents are there or some initial voltage may be there, whatever may be. Okay, so now we are assuming here I of 0 equal to 0, meaning is that before closing the switch, current flowing through the circuit was 0, this is our assumption. But if some current was flowing, then that value we have to include here and we have to solve. Okay, so now we are not considering the initial current. If we do not consider the initial current, then what will be the equation? What will be the value of the current in S domain is? Well, that will be V by S into R plus Ls, isn't it? And that may be written as this, what I have written, V by L by S into S plus R by L. So again you see the denominator, it is of second degree equation. So we can go for partial fraction, that is A by S plus B by S plus R by L. Similarly, if we try to find out the value of A and B, you will get A will be V by R, B will be minus V by R. I think you are able to calculate the value of the constant A and B. Do you have any confusion regarding this?
No, sir.
Okay. So we can write now I of S equal to V by R by S minus V by R by S plus R. So we can have this equation, that is I of t equal to V by R minus V by R into e to the power minus RLT. Any confusion regarding this? Now you see that we are able to solve this differential equation. Initial equation was V equal to R into IT plus L ddt of IT. From that equation we are able to find out the expression of current. So we can easily calculate the current using what we have done? Basically, we have done one Laplace transformation, then some manipulation, Laplace transformation, then we have expressed from that in S domain, we have calculated I of S, then we have taken inverse Laplace transformation to have the value of the current in time domain. So the solution you have got, isn't it? Now, second case, you can see, same thing, step response for RC circuit. If you go through this derivation, I think you will be able to understand. Here also we have considered initial current equal to 0 for the simplicity of the calculation. But in real problem, sometimes whenever capacitor is there, there are chance that there may be some initial current or initial voltage. Okay. So step response of RL circuit, RC circuit. Okay. Next, I have given step response of RLC circuit. And in RLC circuit, same method, but since it is having three components, that expression of the current, that will be that equation will be again second degree, but it is little bit complicated, but you can easily solve it. For that, to find out the value of the current, we have chosen three conditions. Case 1, where all the roots are real, we have considered, and the roots are not equal. First case. Second case, all the roots are equal. Third case, roots are not equal, but they are complex conjugate, and we have solved. If you go through this derivation, I think you will be able to understand. If you do not understand, please ask me in the next class, I will explain. Very simple derivation, a little bit lengthy. Okay, now, okay. Suppose you are asked to find out the response of RC circuit. Try to listen to this question. Find out the response of the RC circuit for ramp. Find out the ramp response. Sorry. Find out the ramp response for the RC circuit. So, what is the meaning? Ramp response means here input is a ramp function. So input voltage will be what? V of t will be equal to, what will be the function?
V by S square.
V by, that is in the frequency domain, but ramp function means V of t equal to A into t or some constant alpha into t, isn't it? It's the ramp function. So you have to write that KVL equation, that is alpha into t equal to RIT plus 1 by C IT dt, integration IT dt. So this is the basic equation. Now we have to take the Laplace transformation, and obviously that Laplace transformation, since it is alpha into t, so alpha by S square, and accordingly you have to solve, isn't it? Now consider so you have to see whether you are asked to find out step response, impulse response, sinusoidal response, ramp response, exponential response. Depending on that, you have to select your input voltage. So far, three cases we have discussed, all three are step response. Now, consider one more different response, like impulse response of RL network. That derivation also I have given to you, impulse response. So impulse response means here input voltage will be impulse function, some value with del of t. Suppose here we have considered E into del t. This is the voltage, E into del t, and it is applied to a RL circuit. So what will be its KVL equation? E into del t equal to R IT plus L ddt of IT. Now, if we take the Laplace transformation on the both side of this equation, then E del T. If we take the Laplace transformation, what you will get? E into del T. What is the Laplace transformation of E into del T?
So only
Only E. So here equation will be only E equal to R into IS plus L into S IS minus I naught. Same case, if we consider that initially no current is flowing, so we can make this I of 0 equal to 0, so we can write E equal to IS plus LS into IS. So I of S equal to E by R plus LS, that is E by L by S plus R by L. So we can have the equation now. I is equal to E by L by S plus R by L. So I of T will be E by L e to the power minus R by L T. Isn't it? Similarly, we can have the impulse response for RC circuit or RLC circuit. Isn't it? Same method. I think you will be able to understand this. Okay. Now you go to that. I have given two problems. Isn't it? And in that two problem, actually, I have it is not written that you have to solve using Laplace transformation, but you are free to use that Laplace transformation or any other method. So consider the first problem. Open that problem sheet, last PDF. You see, again I am going to dictate that problem. The battery voltage is applied for a steady state period. And in that circuit, battery voltage means that is E equal to 10 volt. Obtain complete expression for the current after closing the switch K. Now you see here, switch is over the resistor R2. Assume R1 equal to 1 ohm, R2 equal to 2 ohm, L equal to 1 Henry and E equal to 10 volt. So problem is clear to all of you?
yes,
It is clear. So E voltage source. So here what kind of response? Basically this is source is what? Input is impulse,
Step.
step, step. Okay. So you see, so first let us see. So you have to calculate the value of the current when the switch is closed. Isn't it? Switch is closed. So before the switch was closed, what was the current that you have to calculate?
So 10 by 3.
10 by
3.
10 by
3, sir,
3.
10 by 3.
Yes. 10 by 3. Why 10 by 3?
Because, sir, at t equals to 0 minus capacitor, inductor behave as a short circuit.
Yes.
So, and the current,
Initially, it behaves as a short circuit and that switch was open. So basically that current will be E by R1 plus R2. Isn't it? So in this case you see that before closing the switch also some current was flowing through the circuit. Isn't it? So what is that value? Value is 10 by 2 plus 1, isn't it? So that is 10 by 3. That is 3.33. So I of 0, that is initial current, we are able to calculate from this problem, isn't it? I naught equal to 3.33. Now come to the problem. Obtain the complete expression for the current after closing the switch. When switch is closed, and you have to find out the current for steady state, not initial current. So initially current was flowing, and that current was 3.33 ampere. We have already calculated. Now, when the switch is closed, so we can now, when switch is closed, if we apply that KVL, then what we can write? KVL E equal to R1 into IT, and when switch is closed, R2 is not in the picture, isn't it? It is shorted.
Yes, sir. Yes, sir.
So we can write R1 into IT plus L ddt of IT, isn't it? Now you take Laplace transformation both sides. So that will be E by S equal to R1 into IS plus LS IS minus LS I naught. Isn't it? Now put that value of I naught. And you go for that partial fraction method. So we can write I of S equal to A by S plus that B by S plus R1 into L. Now you calculate the value of A and B and tell me what you are getting. Ultimately, what you are getting? Expression of I of S. You calculate and tell me. Put I naught equal to 3.33 and then you calculate, you go for that partial fraction, that is A by S plus B by S plus R1 by L, where you know the value of R1 and L. R1 equal to 1, L equal to 1, so that will be A by S plus B by S plus 1. So what you are getting? I of S equal to ten by S minus 6.67 by S plus 1, isn't it? Have you calculated? Ultimately, what expression you are getting? I of S equal to 10 by S minus 6.67 by S plus 1, isn't it?
So that plus 10x into S plus by 3s.
Yes? I didn't tell. I'm not getting your
Plus 10 into S plus 1 by 3s.
I am getting here,
Sir.
I have solved 10 by S minus 6.67 by S plus 1.
Then আমি
Yes,
যেটা
yes.
ইনিশিয়াল কারেন্ট ছিল
10 by 3.
সেটাকে 10 by 3 রেখে দিয়েছি।
Okay. So ultimately then equation, then
Sure,
I
sir.
of T will be 10 minus that 6.67 e to the power minus T. Isn't it? So we are able to solve this one. So one more problem I have given. So can you solve that problem? One more problem. You see, initial voltage in the capacitor is, go to the second problem. Here initial voltage in the capacitor is 1 volt. So initially capacitor contains some charge, and due to that charge we are having an initial voltage 1 volt in the polarity shown in the figure. Find the voltage appearing across the capacitor with the application of step voltage. So initially across the capacitor voltage was 1 volt. Now you have to find the voltage across the capacitor when step voltage is applied, that is 2 into ut is applied in this circuit. So can you solve this? Can you solve the problem? How to solve? This kind of problem, you see, one dependent source is there, 4 into I, current I is denoted, one resistor is there, one capacitor is there, two resistors, one of 2 ohm and another of 1 ohm. So can you solve this problem? And you have to solve this using Laplace transformation. So I am giving some clue how to solve. See in this figure, I have given node 1. So in node 1, if we apply KCL, in node 1 we have to apply KCL. Again, in the last node, you have to apply again KCL. And you can apply KCL at the node 1 and node 2. Then you can go for solving that voltage across the capacitor. Are you able to solve? Are you confident? Okay, let us try to solve. So at node 1, if we apply that KCL, so in time domain we can apply KCL, or one thing we can do, we can obtain the circuit for the frequency domain. So there, instead of 2 into ut, we can write in frequency domain 2 by s. Instead of I, we can write I of s. Instead of 4i, we can write 4 of is. Isn't it? And instead of C, we can write 1 by Cs in frequency domain, and we can go for applying this KVL and KCL. So if we apply KCL at node 1, then we can easily write V1 of S minus Vs of S equal to 5 of Is. Isn't it? Are you getting my voice? Hello?
Yes.
If we apply KCL at node 1, you see, at node 1, incoming currents are I isn't it? I and 4I. Outgoing current, that is, to calculate that outgoing current, that will be voltage across, voltage at node 1, that is V1 of S in frequency domain, and voltage Vs. So this difference divided by the resistance R, that is 1 ohm resistance. So we can calculate that current, outgoing current, that is V1 of S minus Vs of S divided by 1, and that is equal to 4Is plus Is, that is 5Is. So one equation we have got, V1 of S minus Vs of S equal to 5S. Now, at node 2, again if we apply that KCL, so current, so node 2, so that will be again V1 of S minus Vs of S divided by 1 equal to Vs of S minus V naught by S, because V naught is the voltage across the capacitor, initial voltage, and what is V naught already given in this problem, that is 1 volt, isn't it? So voltage difference across the capacitor, that is Vs of S minus V naught by S divided by 1 by Cs. So ultimately we got that is equal to Vs minus 1 by S, since V naught equal to 1 volt, by Cs. So we can write now V1 of S minus Vs of S equal to S into Vs of S minus 1. So combining this, we can easily write V1 of S minus S plus 1 into Vs of S equal to minus 1. Now again, if we apply KCL, considering the current I, considering the current I, so I will be how much? Here 2 by S, one voltage source, another voltage is V1 of S. So 2 by S minus V1 S by 2, this is the Is, isn't it? I of S equal to 2 by S minus V1 by S, V1 of S divided by 2. So now this value of Is we can put to the first equation. What we have got, V1S minus Vs of S equal to 5Is, and we can go for solving that. And here what we have to solve, V of S, because V of S is the voltage across the capacitor after applying the step response. So combining these three equations, we can have the equation for V of S, and from that, taking inverse Laplace transformation, we can have the equation V of T. I think this problem is not clear to all of you, isn't it? So let me I am giving you this solution. Actually, I have solved right now. I have given. So you will not understand actually. If so, again, you just try. If you see the solution, you will be understand. If you try to listen to my voice actually. So first, you see, we have to apply the KCL at node 1. After that, again we are applying KCL at 1 ohm resistor, considering the current through 1 ohm resistance and the current through capacitor. These currents are same, isn't it? 1 ohm resistor. And again, we want to calculate the first current, that is I. In frequency domain, that will be I of S. So let me draw that circuit in S domain and let me send you that solution. Okay. 2 ohm.
Sir, yes, sir.
So whatever, after the finish of this class, I shall send you the solution of this. If you are not able to understand, then you tell me the next class. Okay. So I think you will be able to solve any problem
Thank you.
regarding the circuit theory. Any circuit is given. If you are asked to calculate any voltage or any current, you can solve by conventional network theorems. But here also we have network theorems like KVL, KCL, sometimes some other theorem. But using that theorem, we are getting some equation, that is differential equation. And to solve that differential equation, actually, we are taking the help of Laplace transformation. You can also solve that by classical method. But since using Laplace transformation, solution method will be much more easier. And one more advantage is that here, automatically initial conditions are taken care of. Okay. Okay, so today I am going to finish, and just within 1 or 2 minutes I am going to send you the solution. I have already solved, only I have to take the photograph and I have to send it. Okay, thank you. So from next day I shall start with that Fourier transformation. Okay, so day after tomorrow again I can take the class for Fourier transformation. Okay,
sir.
today this much.
Thank you, sir. Thank you.